We are glad to present our paper, Compositional Transduction with Latent Analogies for Offline Goal-Conditioned Reinforcement Learning. Humans can easily reuse the same behavior across changed contexts. For example, we can open drawer easily when the window is open, when we only have the experiences of opening drawer when the window is closed. Our research is motivated by a core question. Can robots leverage past behaviors collected under different contexts to infer the same underlying task? To address this problem, we introduce a new concept that we call analogy transduction, synthesizing goal-reaching behavior by transplanting task endogenous analogies across contexts. In this example, the dataset may not contain any demonstration of opening the drawer when the window is closed and unlocked. However, the agent can extract the analogy for opening the drawer from demonstrations in other contexts, and apply it to the given context. With analogy transduction, our goal is to learn a generalist goal-reaching agent by composing diverse task endogenous analogies and contexts. To enable analogy transduction, we need an effective representation of task endogenous analogies. We first introduce two desirable properties of task endogenous analogies. First, it should be invariant to variations in task exogenous components. Second, it should encode the task endogenous state goal displacement in a sufficiently informative manner for goal reaching. Our first key insight is that, given the optimal temporal distance d star, the metric space induced by this temporal distance is invariant to variations in the task exogenous component. We call this space temporal distance geometry. Here, even if the window state differs across state goal pairs, if the robot and drawer states, which are endogenous components of the task defined by the given state goal pair, are the same, then they share the same task endogenous latent state. This forms a representation that is invariant to the task exogenous context. However, a single temporal distance from the starting state S to the goal state G degenerates, since there exist lots of state goal pairs with same temporal distance. Our second insight is to represent the task endogenous displacement from the starting state S to the goal state G using a distance difference field. This is motivated by prior work in differential geometry, where such a field is known to identify each point. In our paper, we formalize the two aforementioned conditions and define the task endogenous analogy. Our main proposition establishes that, under a few acceptable assumptions, temporal distance difference field is a valid task endogenous analogy. You can find the detailed theoretical analysis in our paper. To obtain a representation of the temporal distance difference field in continuous state spaces, we parameterize the temporal distance in a bilinear form and learn each encoder using the ICML objective with a modified reward. We then use the displacement between the goal head representations as an approximation of the distance difference field, which we define as the dual analogy. Now, recall that the analogy transduction refers to the synthesis of goal-reaching behavior by transplanting task endogenous analogies across contexts. What if the agent has never performed the corresponding task in the given context? We tackle with this problem by interpreting goal-reaching as an out-of-combination extrapolation, so that we could reach the goal by transplanting task endogenous analogies to the given context, which are never observed together. We propose CTA, an effective algorithm for the analogy transduction that enables out-of-combination extrapolation by adopting bilinear transduction. Specifically, we parameterize goal-conditioned value function and hierarchical policy mean with bilinear transduction, and this enables estimating values and extracting actions to out-of-combination analogy context pairs via extrapolation. The main experiment to test the generalization performance of CTA includes evaluations on 8 manipulation suites of OG-bench benchmark. For additional experiments and analyses, please refer to the paper. CTA achieves the best or near best results on 6 of the 8 tasks and improves the overall average performance by about 42% over the strongest baseline. The symbol superscript V denotes a variant that incorporates the dual goal representation into the original algorithm. In particular, the results in the last 3 columns suggest that the generalization performance of CTA comes not from the dual goal representation itself, but from analogy transduction. Remarkably, the gains are most pronounced on puzzle environments, where the exponentially large state space makes compositional generalization critical. To test whether CTA indeed extrapolates to out-of-combination context task pairs, we construct direct out-of-combination case studies on scene and puzzle 4x4 by holding out some selected pairs from training and evaluating them at inference. For example, one held-out pair requires opening the drawer when the window is closed and unlocked and the drawer is closed. Since the goal can still be achieved through an indirect in-distribution sequence, we report a direct success rate, which counts only trajectories that solve the intended held-out task directly. CTA achieves the highest direct success and success rates in both environments, suggesting that baselines often prefer indirect in-distribution executions, whereas CTA directly solves unseen context task combinations more reliably through analogy transduction. This video shows the results of the direct out-of-combination case study in the scene environment. CTA often reaches the target goal directly, whereas dual HIQL tends to rely on in-distribution detours, with a lower success rate. To qualitatively verify that the dual analogies capture task endogenous displacements, we sample 20,000 state goal pairs from the recollected validation split of scene play and visualize dual analogies using a 2D TSNE projection. We can see that similar task analogies lie close to one another in the latent space, so we conclude the dual analogy indeed capture task endogenous displacements. Thanks for your attention, and feel free to contact us if you have any questions.